Welcome to the PLUTUS IAS. Today, in continuance of the videos on Geography GS, we are discussing about today IOD, right? Indian Ocean Dipole, and how it is related to the El Niño phenomenon. Since during the El Niño year, which is quite affecting the monsoon negatively, but it is seen that during the El Nino years, monsoon is not so weakened. Why? The cause is there of IOD. Hence, today we will discuss about IOD. IOD means to Indian Ocean Dipole, where there is formation of two poles in Indian Ocean. You have West Indian Ocean and East Indian Ocean. If there is a pressure difference found in Indian Ocean, such kind of pressure difference would be measured in terms of Indian Ocean Dipole, right? Indian Ocean Dipole is divided into three phases: neutral, positive and negative dipole. Positive Indian Ocean Dipole is directly related to the El Nino. In the years of El Nino, if there is presence of positive Indian dipole, then the impact of El Nino would be cancelled out, right? How does it possible will be seen in picture. So simply this is about India. And one side is having with, say, Arabian Sea, Bay of Bengal, right? So we'll see here nearby the Africa, right? So this is the point here. This is the point here. Studied as, see, if the pressure is P1 and pressure is P2, if the pressure of P1 is greater than P2, pressure of P1 point near Africa and near Indonesia. So this pressure 1 is greater than pressure 2. The phase of Indian Ocean is identified as positive, neutral and negative. First, see, in neutral phase, what happens? P1 is greater than P2, right? P1 is greater than P2, and temperature of, since pressure is the product of temperature, hence the temperature of what you say T1 is what you say less than T2, which results into more P1 in the region of T1. Because of high temperature of this region, suppose, then the pressure of the region would be less. If more temperature is there, then pressure would be found less in that particular region. So suppose if the temperature of that region is more and temperature of that region is comparatively less, then the situation would be there as with more pressure and less pressure. So the combination could be made as P1 is greater than P2. That is, more temperature is there in East Ocean than to West Ocean, then the condition would be neutral. And this is of the phase of positive dipole, where see temperature of here T1 is greater than T2. T1 is greater than T2. Right. Earlier the situation was there T1 is less than T2. So positive is there. On the same way, negative dipole is again saying against or opposite to positive dipole. So here T1 would be less than T2. So neutral and negative is more or less similar, but the basic difference would be there. That could be discussed here in class. So now we'll see about how these temperature differences causes different kind of impact over the climatic conditions of East and West Pacific, right? So when the temperature of, see, in a situation where there is more temperature in eastern part of Indian Ocean, which results into formation of low pressure region, air would have normally tendency to be higher up, will be subdivided into two parts, and finally it would subside in, see, western Indian Ocean region nearby the Africa, near Mascarene Island of Africa or Indian Ocean, making high pressure, and following this high pressure and low pressure of P2, winds has got the tendency to be flowing from P1 to P2. This is a particular type of circulation develops over Indian Ocean, right? Develops over Indian Ocean. But what happens during the this, what you say, neutral phase? Since we are discussing first about the neutral phase, there is some kind of trade wind in southern hemisphere which comes to northern hemisphere in the form of monsoon, right? In the form of monsoon. When there is high pressure at the Mascarene Island, this high pressure makes a push for the trade wind to be attracted towards the low pressure region of India during the summer season. So the southern hemispheric trade wind will have the natural tendency to be shifting towards the India. Hence, this pressure condition of P1, which is greater than P2, supports the movement of southern hemispheric trade wind in the form of monsoon to India, right? This is the case of neutral phase of monsoon. But there is a caveat. that see some parcel of this wind will have the tendency to be dragged towards the P2 because there is a gradient which see will force some trade wind while entering into Arabian Sea or what you say western part of Indian Ocean to be dragged to some extent towards the P. So the see amount of humidity that was possible to come to India will be reduced and certain parcel will be moved towards the P2 eastern Indian Ocean and the intensity of monsoon would be decreased. So see in case of neutral pH normally it is said as out of 100 see 70 or 60 part would be reaching to India, right? But in case of see negative dipole like that, if see the condition is there where significant amount of here southern hemispheric trade wind will be dragged towards the P2 because of the strong gradient found between P1 to P2 and see monsoon would get reduced or what you say humidity of southern hemispheric trade wind which was supposed to be coming to India would be reduced. So out of 100 see if only 50 would be coming to India, 50% or even to less amount comes to India, then the situation would be termed as negative dipole. But what if see certain condition is there when see the temperature of western Indian Ocean is higher than to eastern? How is it possible? Since during the monsoon months, if certain kind of wind which becomes forceful to drag warm water of normally the water of Bay of Bengal or what you say nearby the Indonesia Indian Ocean is higher because more and more see rivers are draining. For example, Ganga, Brahmaputra, see Godavari, Krishna, Irrawaddy of the Myanmar, all are draining into Bay of Bengal. This fresh water which is draining to Bay of Bengal or what you say Indian Ocean making thin layer over the eastern Indian Ocean, and this thin air is more able to be heated by the sun, while see warmer air is found on the surface region, comparatively colder air lying below, making such kind of stratified arrangement. Hence the region is more heated. Normally Bay of Bengal is more heated, but because of the impact of wind, certain wind during the monsoon months, if the warm water of Indian Ocean is dragged towards the western Indian Ocean, see the western Indian Ocean is becoming heated. This heated region results into low pressure development in that region, which results into see some opposite kind of situation to be formed, where see there is more temperature, hence water would get heated and low pressure region would be developed, air of that region would get rise, then subdivision would be there. So in place of such kind of high pressure to be developed in that region, there is low pressure, and subsequently high pressure of P2 would be changing into what you say, sorry, low pressure of P2, since the Bay of Bengal or eastern part of Indian Ocean was more heated and was potential low pressure region, would be changing into high pressure situation. So the air would be uplifting from Western Indian Ocean and finally will subside to the higher pressure region. So now the wind has got the tendency to be moving in this direction opposite to earlier moving from P1 to P2. Right now winds has got the tendency to be moving from P2 to P1. Now what happens to southern hemispheric trade wind when it comes to that region? Although there is a low pressure, but this point will be having with absence of mascarene high, but there is no any such kind of gradients towards the eastern Indian Ocean. Hence, this gradient from P2 to P1 will support the southern hemispheric trade wind to remain in western Indian Ocean, and this western Indian Ocean water where there is presence of huge amount of humidity coming from southern hemisphere will easily be dragged to India where there is a low pressure. Since northwestern part of India during the summer season is heated and is becoming low pressure region because of the more temperature, hence is a region developing into potential low pressure. So respective high pressure region to the low pressure region, there is a gradient to be formed earlier. This gradient will support entire 100% of the humidity of western Indian Ocean to reach to India. Then see how it is impacting over the El Niño. Since El Niño was the phenomenon which was causing decrease in the intensity of southern hemispheric trade wind to come to Indian Ocean. See, this is the trade wind which was earlier not able to cross to the Indian Ocean. But this phenomenon is there of positive dipole formation, which makes such kind of gradient towards the western Indian Ocean. Then the trade wind of that part or that region will easily be dragged to India. So such kind of positive condition is there developed in Indian Ocean, which de-intensifies the impact of trade wind to come to India, because there is a pressure gradient towards the western part of Indian Ocean, which leads the southern hemispheric trade wind to come to India. Although all the dipole is impacting, whether of neutral, whether of negative dipole, but positive dipole is more impacting the negative impact of what you say El Niño to India. So this is about the impact of Indian Ocean dipole over the progress or impact of El Niño. Next day we will be discussing about the similar kind of topic related to either monsoon or some kind of climatic phenomenon. Thank you.